So remember, for this homework tonight, it must be done on graph paper, right? Like the other one. Recall that I have these special handouts. If you want to look at tomorrow, anything that says done on graph paper, you can always click on it. Scroll down. And you pull this up. There are all the problems for your homework already on paper. And you can do it on there. Now, the one downside of this is that it takes 3 pieces of paper for this one assignment. If you do it on regular graph paper, you probably just need the front and back of one piece of paper. Sometimes it's just more convenient and whatnot if you're on the road or whatever. Fair enough. Of course, we had several people came in this morning and print all these out for the whole week. Now they have it for the whole week. So do that as well. Okay, so make sure you do all of it. And let's look at it anyway, since we're looking at it. What are you going to be graphing? You're going to be graphing absolute values. So we've done a lot of problems with solving equations, solving inequalities of absolute value, but we've never actually graphed it. So this is the first actual algebra 2 you're learning today. First thing that's really new. Everything else has been reviewed so far. The good news is it's not too far removed from what you already know. So we're going to do a little review. We're going to build you up to what all this stuff means. You have to know a little bit of vocab. That's not a problem, though. Here we go. What would all these look like? What would y equals 1 look like? Yeah, you guys did that last night on a few problems, 21, 22. Those are called constant functions. A constant function really just means that the slope is equal to 0. Just like on your homework. Okay? I could rewrite this as y equals 0x plus 1. Rewrite it as 0x plus 1. But if 0 times anything is 0, that's why we drop it. So a constant just means slope is 0. So a horizontal line. What is the domain of constant functions? Domain. So what numbers are you allowed to plug in? All reals. You can plug any number in here. All reals is the domain for any constant function. Because you can plug in anything for x right here. So plug in 10. 0 times 10, 0 plus 1. You can plug in any number. You're allowed to plug in any number. What's the range? So what are all the possible answers here? So pick some negatives, see what the answers are. Plug in 0. What's the answer? Plug in positive. What's the answer? That's your range. So plug in some negatives. What do you get for an answer? One. Negative a million. Okay. 0 times negative a million is 0. Plus 1. Answer is 1. Negative 2. 0 times negative 2 is 0. Plus 1 is 1. So anytime you plug in negatives, you get an answer of 1. You plug in 0, you get an answer of 1. You plug in any positive number, you get an answer of 1. So the range is 1. All your answers are 1. So you can see how here and here it's always the same. For a constant function, the number you see here is the range. It's always going to be the same. We said y equals 3, the range is going to be 3, because all the answers are 3. No matter what number you plug in for x, you get an answer of 3 if y equals 3.
Do we have to draw those little line, like the little bracket things on the outside one?
Yes.
I can never get those.
Right, just make sure
Always come out real ugly.
those are pretty. They're trying hard, I'm sure. All right, identity function. Okay, this. Take that off. Identity function. This basically means it's linear. And the graph is a straight line, of course. That's what linear means. Y equals x, that's similar to y equals what we already know, mx plus b. So if it's in this format, it's identity or it's linear. go with identity. If it doesn't have all these other numbers, just say okay. What's the domain and range of these? What numbers are you allowed to plug in? Is there any number you're not allowed to plug in? And if this is too abstract, just come up with some actual numbers. Say the slope of, right close by. Can you plug in positives? Can you plug in negatives? Can you plug in 0? Yeah, you can plug in everything. All reals. What are my possible answers? If I plug in negatives, I can get some negatives. If I plug in 0, okay, I get 5. If I plug in a lot of positives, I get positives. So my range is all reals as well. So I can get any answer. I can get any answer on this. So range, let's say, is the same, all reals. What about here? Absolute value. What numbers am I allowed to plug in? Is there any number you cannot plug in? Can I plug in negatives?
Yeah.
Can I plug in 0? And can you plug in positives? Yeah. So you see, every time, for each of these with the domain, I always ask those 3 questions. You know, do negatives work? Does 0 work? Does positives work? So those are all reals. Now, what about the range? What are some possible answers? Do we get negatives, 0, and positives for answers?
No.
No. What's missing? Someone said it. What is it? Negatives. Can you get negatives from this?
No.
No. You plug in negatives, you get positives. You plug in 0, you get 0. And if you plug in positives, you get positives. So the range is not going to be all reals. It's possible to get a negative answer. So you can say just like this. Why? The way you say 0 positive is greater than or equal to 0. So it can be 0 or bigger than 0. So it can be 0 or positive. There's your. Now somebody asked, since all these domains are all reals, they're like, well, what's an example of something where a domain is not all reals? Here's a very good one. Y equals the square root of x. What's the domain here? Can you plug in positives? Can you plug in 0? Can you take the square root of 0? No. Yes. Square root of 0 is equal to 0. No. So 0 squared is 0. Can you plug in negatives? Can you take the square root of negatives? No. You have your calculator in front of you. Try it. Square root of a negative. Square root of negative 2. What does it say?
It says.
Error. Syntax. Something like that.
Ooh, domain.
Or it says domain error. What we're talking about. Domain. So yeah. All the x's have to be 0 or bigger or positive. So there's an example of where the domain isn't all reals. You can't plug in negatives anywhere. Okay? And the range here will also be the same. You can't get a negative answer either. So you can't plug in negatives, and you can't get a negative answer. So both of these are going to be 0 and above. So there you go. That's a good example. We don't have all reals for them. And we'll get to graphing these later. This is algebra 2. We'll be graphing square root of x and all sorts of fancy stuff later. So you'll know when you're graphing this, since you can't have any x's that are negative, you won't have any of your graph over here because none of the x values will have enough. They'll just start right here and go like that. It's only positive x's and only positive y's. All your graphs will be just right here in the first quadrant. Because it's impossible having negative x and negative y. You won't have anything down here either. The domain and range kind of tell you what the graph will look like without doing all the work. So let's use all this information and get Again, the biggest thing you want to be able to do today is explain absolute value. Okay? All the other things we've seen so far, the absolute value is the new one. All right. So, what kind of function was this called again? Looking at your notes. Look at your notes. You wrote it down, right?
Absolute.
Yeah.
Identity.
Yeah. Already, if you're just taking notes means watching, sure, this should be on your paper. That's an identity function. If it's on the quiz, on a group quiz, you should be able to pull up your notes and say, hey, that's identity. So again, if you're just sitting and watching instead of doing what you're supposed to be doing, get on it. Okay? Identity. All right, this is, it has a square in it. It's quadratic. Let's call it quadratic. Guys did a little bit on this. What was this called again right here? When it's equal to a number? Looking at your notes. This thing was called a identity. And of course, this is the absolute. Now, what does f of x equals x look like? Remember, f of x is like the cursive for y, so it means the same thing as y equals 1x. So y equals 1 over 1x plus 0. So think of it that way. You guys are going to use f of x. It's still a little confusing. Just think of it as y equals is like print, f of x equals is like cursive. It means the exact same thing. Write it a little bit. What would this look like? This means the y and the x are the same number. So if x equals 1, y equals 1. So your graph is 1, 1, 2, 2, 3, 3, 4, 4. This ends up looking like that. It's 1 over 1x plus 0. And of course it goes down here as well. That's what it looks like. It's like nice, straight line. What would something like this look like? Basically the same thing, right? It's just plus 2. So everything is moved up 2. Just like that. So if you know like the basic graph, also known as the parent graph, which is this, the blue one. If you just add 1, subtract 1, and multiply by 4, it's basically the same parent graph, it's just moved in different ways. Like 4x minus 1, this one right here. Okay, it's moved down 1, and then you have to go, what, up 1, right 4. So it's the same thing, it's just kind of moved around different ways. This one, minus 6, up 1 over 2, something like that. Just in general, just kind of sketching it. The same thing will happen with quadratics. F of x equals x squared, it looks something like this. Here's a parabola shape. Now, what happens if it's x squared plus 2? It's the same thing, just moved up 2, right? Same exact shape, moved up 2. Notice how it's the same relationship between this blue and green line. Is this straight line just moved up 2, now it's moved up 2. So having that plus 2, it does the same thing on both. That's what I'm getting at. It's the same thing that happens. Doesn't matter if it's a straight line or a parabola. The same thing happens with any graph if you just put a plus 2 on it. Same idea here with 4x. The 4x here, it kind of made it a little steeper. right? The red one made it a little steeper. The 4x here, we'll just make it steeper on each side, which gives it the appearance that it's skinnier. And of course it's down 1, so down 1. So it looks like this. Gives it the appearance that it's a little steeper than all the others. So kind of same but different. You know, this red line is steeper, and this parabola is steeper, which makes it look skinny. What about the 1/2 x squared minus 6? Over here, it kind of, well, it started way down at minus 6, and it wasn't as steep. So for the parabola, what will that look like? Still starts at -6, and it's kind of wider, not as steep. So the steepness and the wideness are basically the same thing. Right. Constant, a little boring. Not much going on there. Y equals 0, f of x equals 0. Looks like this. Straight across. You guys saw that 21 and 22 last night. Constant functions, just straight across. Why is it called a constant function? Remember? Yeah. The answer is constant. Your range. There's only one answer for your range. It's 0. So your answer is constantly 0. No matter what number you plug in to y equals 0x plus 0. You plug in negatives, you plug in 0, you plug in positives. Your answer is constantly 0, no matter what. That's why it's called a constant function. And again, we have the 2. That just moved up 2. Oops, should be a straight line there. The -1 has just moved down 1, and so on. So let's use this pattern for absolute value of x. Okay. What will happen here? All right. Now imagine this. Y equals x. Same thing we have right here. F of x equals x. If you plug in 2, what do you get as your answer? What's the absolute value of 2? 2. So 2, 2. If you plug in 3, what do you get? 3. Plug in 4, you get 4. Yeah, right? Isn't it the same thing we did over here? It's identical. It's identical. Okay, but what happens when you plug in negatives? Okay. You plug in -2, what do you get? Positive 2. So it goes right here. Plug in -3, you get 3. Plug in -10, you get an answer of 10. So the graph ends up looking like this. If you plug in 0, you get 0. Notice how it's basically the same thing here. It's just that this whole part, all this from here to here, the blue, these are all negatives, and now they've been rotated up. All those negative answers became positive. So it's kind of like this whole negative part of y equals x became positive. It rotated 90 degrees exactly. Geometrically. So, and now let's look at the base. So we know that x plus 2 just moved the whole graph up to here. We moved x squared up to, and so on. Even though the constant function f of x equals 2 and moved it up to. What do we think it's going to do here? I think it moves the whole absolute value up to 2. It does the same thing it would for any graph. So this right here, having a plus 2, is universal for any graph. It just moves it up to 2. So there's no, what I don't want you to think is that there's a bunch of new rules now for absolute value. Same stuff we always had. So same thing here. 4x minus 1, you can see the graph right here. It's the same thing here. For positive, it's identical. So from here to here, and here to here is identical. It's the same exact thing. It's just now all these negative parts, it's like they're rotated up here. So instead of going down this way, we're going to go this way. That's what the absolute value is like that. So if you know how to graph without the absolute value, you have half the graph already, the positive half. the negative half will just be a mirror image. Same thing here. We can go down 6, right? And since it's 1/2, it'll be a little bit wider, something like that. Now, without the absolute value, this will keep going like this. Because we go down 1, left 2, down 1, left 2. But instead, it's going to be like a mirror image. Go back. So that's the big idea here. How are we actually going to graph these? We're just going to do an old-fashioned T-chart. That's what you're going to do for each of your problems tonight. On your paper here, you see how much room there is? You can make a big old T-chart, plug in some points, and see what happens. Always plug in some negatives, 0, positives. If you can figure out what the x-intercept is going to be, use that as well. Remember, x-intercept is when this will be 0. So what number would you have to plug in here for this to be 0? -1. So when I say some negatives, 0, positives, yeah, make sure, okay, one of your negatives is -1. So I can use, how about -4? I use -1. I use 0. And I'll use +1. I use +4. You can pick whatever numbers you want. Just have some negatives, have some positives, have 0. Make sure one of these numbers is the x-intercept. It could be a negative, it could be 0, it could be a positive number, depending on the problem. Okay? And then use this notation. F of -4 equals, plug it in, -4 plus 1. And you'll just continue on. F of -1 equals absolute value of -1 plus 1. Now, as you're doing this, you can do two things in your notation. Notice how I'm trying to write the numbers on the inside of the absolute value a little bit smaller. Because you don't want to confuse these right here for ones. You don't want this to look like 1 minus 1 plus 11. So you can do two things. Write the numbers inside a little smaller, or just press down harder on the absolute value bars so they're a little bit darker. And that way you'll never confuse it. There's nothing more frustrating on a quiz or test. Oh, I missed it because I thought that was a 1, not an absolute value. Okay, you have to be able to read your own writing. So that's a little thing that will help you. Yeah, and this is it. It's just old-fashioned T-chart. Plug it all in. Now, do you have to use this notation? Do you have to write it out exactly how I'm showing you to write it out? Yes, the both. Okay, so don't come in tomorrow and say, oh, I don't like f of x, I use y. Okay, you're going to use this new cursive type of math. No, yes, it's a different way of writing it. You want to know how to use it properly. Go ahead. Graph everything. So, here we go. -4 plus 1. -3. Absolute value of -3, though, is 3. -1 plus 1. 0. Absolute value of 0 is 0. 0 plus 1 is 1. Absolute value is 1. 1 plus 1 is 2. Absolute value is 2. 2. And 4 plus 1 is 5. Absolute value is 5. So here's your x, here's your y. And you go ahead and plot. So we have -4, 3. -4, positive 3. We have -1, 0. We have 0, positive 1. So we have my x-intercept and my y-intercept. That's nice. -1, 2. Positive 1, so positive 1 and 2. And 4, 5. And then since you know what the shape generally looks like, you can go ahead and do this. Of course, you use a straight edge here. What's the domain? What numbers are you allowed to plug in? Not all real. You can plug in any negative or any 0 or any positive, right? Now, what's the range? what's the range here? So do you see any y values down here?
No.
Yeah, remember, y's are the answer. All these numbers, all these y's, that's your answer. So you can see all these y's have no graph. That means they're not answers. So none of these negative numbers are answers. So that means f of x, same as y, okay? Y has to be greater than or equal to 0. See, 0 is an answer. And all these positives, see all these y's up here? These are all positives. All these answers right here. All positive numbers and 0 are possible. There are no negative answers. So y has to be bigger than or equal to 0, or same thing as saying f of x has to be bigger than or equal to 0. So in general, make your table, graph the points. You're going to use a straight edge so it's symmetrical, and then you can come up with your domain and range. That's going to be your process. As long as you keep things neat and organized and don't skip anything. So again, when you guys come tomorrow, everybody to get credit will need to have all of this part right here. I know it's new, and that's why we're going to have you do it. You're going to have to show all the work. And of course have your answer. Okay? Make sure you do everything fully and complete. We'll spend the first few minutes going over questions, but if you don't get anything tonight, I see you tomorrow at 7 a.m. so we don't fall behind.
Wait, what? Wait, what?
Okay, good luck.
Wait, what?